Alright, so like I said, we're going to get into multiplying and dividing rational expressions. So the first thing that I want to talk about is just our basics, right, for simplifying. So in order to simplify using division, right, when we have a rational expression, we need the exact same thing on top as we have on bottom, but through multiplication, right? So is there anything that I have in common in this top equation? See, so what can I do? Cancel it off, and what do I get? Every super easy, right? Well, you guys remember this, right? Okay. 15 over 65, is there anything in common between 15 and 65? Common factor. 5s, okay, so what's 15 equal to? 5 times 3, and the bottom is 5 times... So now what can you cancel out, though? And what are you left with? 3 over 13, right? Yeah, I just want to show it because it'll make more sense when we get down here. Okay? So if you notice here on the top equation, right, we have the same thing being multiplied together. We have a times c and a times c, so they can cancel. In the middle one here, we have a times 5 and a times 5, so they can cancel. So on the bottom, what we're looking for is we're looking for repeated factors, right, that are connected through multiplication. So look at this one, top and bottom. Is there anything in common from top to bottom that's isolated by multiplication? Yep. The x plus 3s, right? 4 times x plus 3 on the top, then x minus 5 times x plus 3 on the bottom. So remember, parentheses act like our dividers, right? So anything that's contained within parentheses on top and contained within parentheses on bottom can cancel just like a number. Because x plus some number is still going to just be a number, so we can treat it like it's a 5 or whatever. Simplifying a rational expression with polynomials. There we go. All right, everybody okay with the basic idea? All right, so let's take a look at the top one here. First of all, again, what did the directions say to do? Simplify, which means make things smaller, right? So we're going to perform our typical math stuff where we're actually going to make things bigger, look for common pieces that can cancel from top to bottom, then put it back together again, resulting in a smaller end. All right? So you remember the first packet we did? It was on factoring, right? So I want to factor the top, factor the bottom, and look for anything in common. So I have 3 pieces on top, so now I'm going to factor out like this, right? And go through our regular stuff. We'll multiply together to get x squared. And x. Okay, 2 numbers that multiply together to get 15, but when you subtract them, you get 2. 5 and 3, are the signs going to match or be different? Different, and their bigger one is negative. So I get a minus 5 and a plus 3. Everybody okay with how to factor out just the top? Okay, so now we're going to factor out the bottom. X and x, right? I need 2 numbers that multiply together to get 9, but when you subtract them, you get 0. X plus 3 and x minus 3, very good. Now I have just multiplication on top, and I have just multiplication on the bottom. Everybody okay with that? Like, I really don't care what's going on inside the parentheses. The main thing is that everything's blocked off, and the only connector is the multiplication. So now I'm looking for things being multiplied together, which is the definition of a factor, that matches on top and bottom. So do I have anything that matches on top and bottom identically? Okay, so what am I left with? Okay, and is there anything else I can do to make this smaller? Actually, I can't because it's got the subtraction attached to it. Okay, so when you're canceling, you can only cancel if you have multiplication. That's why we knock this down using factors, so we have multiplication on top and bottom, so that way we can cancel. All right? So this is our final result. Is everybody okay with that process, you think, maybe? Bottom problem here. 40x plus 20. Is there anything I can factor out of those two? 20. Okay, and what does that leave me with? Oh, 2x. Yep, plus 1. Everybody okay with that? Yes, no, maybe? Okay, what about the bottom? 10x plus 30. What can I factor out? 10, and what does that leave me with? X plus 3. All right, so do I have anything that I can straight up just cancel? Like anything that matches identically? No. So what I'm going to do is I'm going to try to reduce. So can 20 over 10 be reduced? Okay, to what? To 2 over 1. But where's the 2 going to go? Does it go on top or on bottom? on top. Why? Right, 20 is bigger than 10, right? So the bigger number's on top here. After we reduce, the bigger number still has to be on top. So we're going to get 2 times 2x plus 1 all over x plus 3. You can leave it like that, or go all the way down to that. Either answer will be sufficient for this course, okay? But again, when you take the ACT, if you seniors are planning on retaking it, it might be this format or it might be that format. Again, the important thing is that you know how to move between the two forms. Multiplying rational expressions. Now, dividing rational expressions is very simple if you know how to do this part. So this is kind of like the big section, okay? If you can do this, you should be able to do the other two versions really easy, okay? Because in order to multiply properly, you have to be able to simplify, and division is just like multiplication. So what's A over B times C over D? So how do you multiply fractions, first of all? Straight across, right? We crisscross if there's an equal sign here, and the only other time that we do the crisscross thing is when we're trying to get a common denominator, which means that it's a plus or a minus. Okay? So for us, we go straight across, so we get AC over BD, and can anything cancel from top to bottom there? No. Okay, so this is a very simplistic idea to what we're going to really be doing, which is multiply the two rational expressions together to get a single fraction, and then simplify from there. Everybody all right? Yes, no, maybe? All right, so down here, let's multiply the tops. So what do you get when you multiply the two numerators together? So let's go one piece at a time. What's 5 times 6? 30, right? X squared times x becomes x cubed. And I don't have a y to go with the y, so the y just carries over as is, because it's 1 times y cubed. Everybody good with that? Yes, no, maybe? All right, so now multiply the denominators together, and what do you get? 20xy cubed. Right? Everybody okay? Okay. So if you notice, what's the only operator I have in play on the top and on the bottom? Like on the top, what's the only operator connecting these three pieces? Addition, subtraction, multiplication, or division. Right. All multiplication here. What about on the bottom? All multiplication. Before I can simplify, I have to have that. I have to have multiplication as the only tool being used. Okay, that's why over here, the first thing I did was change from having addition to having a form of multiplication to see if I could simplify. So we basically have 3 different bases that are in use here. We have the whole numbers, we have the x's, and we have the y's, right? Okay, so 30 over 20, can that be reduced? Okay, to what? 3 over 2. So I still have a 3 on top, and I'll have a 2 on bottom. What about x cubed over x? X, what? So I can get rid of how many x's? I can get rid of 1, which leaves me with x squared, and it's going to be on top because 3 is bigger than 1, right? And then what about y cubed over y cubed? They cancel out entirely. So what do I get for a final answer? 3x squared over 2. This stuff takes a little while to get used to. All right, working through it. So, but the concepts here are going to be huge because the next 2 sections are addition and subtraction. So we're going to be adding rational expressions and subtracting rational expressions, which means that you're going to have to get common denominators. We need to make sure that we're okay with multiplying expressions together here, remembering all your power rules, right? Dividing, so that way we remember to subtract. All of that stuff is going to show up. All right, so let's look at a bigger one. Now, if I just were to multiply this together, right, what's x squared times x squared? X to the 4th, right? Have I ever shown you how to factor down an x to the 4th? No. So, do you really think I'm going to just multiply everything together? No, because we're going to get to a point where we don't know how to get back from. So what we're going to focus on instead is when I multiply these, I take the numerator times the numerator, right, and it gets written as a single numerator. So what I'm going to do is I'm going to factor each numerator as I go. So 3x minus 3x squared. Is there anything I can do to make that smaller? Is there anything in common that I can pull out? 3x. And that leaves me with that. Is everybody okay with how I factored that out? Yes, no, maybe. Because this is your time to ask. Yeah. So you're good with the 3, right? And then I have an x and an x squared, so I pull out the x. So what I'm doing here is dividing. So what's 3x divided by 3x? Right, anything divided by itself is 1, right? So that's how I got the 1. And then what's negative 3 divided by 3? The negative 1, right? And x squared divided by 1x is just the x. So remember, whenever you factor anything, if you're not sure, multiply it back out, and you'd better get right back to where you started. So 3x times 1 is 3x. 3x times negative x is negative 3x squared. So that means that I did it right. Okay? So what about here? X squared plus x minus 20. If you see 3 terms, right, how do I get x squared? X and x, I need 2 numbers that multiply together to get 20, but when you subtract them, you get 1. 5 and 4, right? Are the signs going to match or be different? Different, but the bigger one is positive. So what about x squared minus 4x, or sorry, plus 4x minus 5? That can be factored, I hope. Let's see. Multiply together to get 5, subtract to get 4. That's going to be a 5 and a 1, right? Signs are different. Bigger one's a positive. And then that leaves me with the 3x. Everybody okay so far? Yes, no, maybe? And if you notice, I'm putting everything into parentheses, right? That's what I want. Okay, because when everything's broken off into parentheses, I'm creating groups that I can try to cancel with from top to bottom. So now that I have everything split apart into its base pieces, is there anything that matches from top to bottom? X plus 5's match. Anything else? Well, x minus 1, and this is 1 minus x. Is that the same thing? Now, this is technically a negative x plus 1 like that, right? Okay, I have the 3 x's. Is there a way that I could make this look like that? Is there anything that I could divide each of those numbers by to get this? Negative 1. So what I'm going to do is I'm going to factor out a negative 1 here. And that's going to leave me with a positive x minus 1. Everybody all right with that? It's kind of a tricky move. Okay? Kind of the sign that we needed to do that is if you have an x with a negative on it, we always like to make them positives. So I should have pulled out a negative 1 right here. I just didn't catch it. Okay, but is everybody all right with how I made negative x plus 1 be negative 1 times x minus 1? Right? Just playing with the signage. So now is there anything that matches? The x minus 1 matches with that, right? And that's out. So that leaves me with a negative 1 times x minus 4 on top all over what goes on the bottom. 1. Right? Because we're using division, so you'll just have a 1 on the bottom. So if I multiplied this out, your final answer would be negative 1 times x minus 4, or negative x plus 4. So this disgusting thing became that. Okay, now, does everybody recognize that this right-hand piece is actually a fraction, or no? So anything is a fraction, right? Every number can be written as a fraction by putting it what? So this is actually that big disgusting thing over 1 being multiplied together. All right. We're going to build it the same basic way. Okay, can I simplify x plus 2? No, so that's just x plus 2, right? And then I need to factor down, I'm going to kind of run out of room here. Factor down x squared plus 3x plus 9. So again, where do I look? A, B, or C? A, right, which is the x squared, so it multiplies together to get x squared. X and x. I need 2 numbers that multiply together to get C, but when I add them, well, that's mathematically impossible. Well, shoot. Oh, you're joking. Can I factor down x squared plus 3x plus 9? No, so it's just got to hang around in its current format. And we're going to throw it in parentheses so it looks like it's multiplication, right? I can't do anything to make it smaller, so the only way I can get rid of it is if I get one of these down underneath, right? Okay, so I've got an x cubed minus a 27. Do you guys remember that 27 is a perfect cube? Right? What number cubed is 27? 3. So this becomes x minus 3 times x squared plus 3x plus 9. How do I know that? We had a rule in chapter 7, how to factor down the difference of perfect cubes. Okay? I don't remember the exact page number anymore. I used to know it. Go back through chapter 7 and find it. Okay, there's two formulas, one for when it's the addition of cubes and one for when it's the subtraction of cubes. You need to know it. All right? Everything we did last year, you're expected to be able to just use and recognize that you need to use it. So when you see something cubed minus a perfect cube, you know that's the rule you're using, right? And the rule says if you have x cubed minus, we'll call it y cubed, okay? This becomes x minus y times x squared plus xy plus y squared. All right, that's what the formula says. So for us, this is x cubed minus 3 cubed, right? So this is the same thing as x minus 3 times x squared plus 3x plus 9, because 9 is 3 squared. Everybody okay with what I was doing? Yes, no? Do you guys remember seeing that? No? Okay. I know you put it down on your cheat sheets last year when we got into chapter 7. So it's one of those things that if you don't have it anymore, right, if you don't remember seeing it, you need to look it up. It is in your book, and I'm pretty darn sure it's in chapter 7. It might be in chapter 6. All right? It's just the difference of cubes formula and the sum of cubes formula. They're right next to each other. Make sure you have those. All right, so now, as far as the actual problem goes, can anything cancel from top to bottom? All right, this entire chunk takes out that chunk, right? So what's your final answer? X plus 2 over x minus 3. All right. So again, what's tricky here? This thing, right? Yeah, I would definitely recommend you have it copied down for your next quiz. Put it on the cheat sheet. For your test, put it on the cheat sheet, okay? It's going to show up. But again, there's an indicator. What's the indicator? X cubed minus a number. If you ever see that, there's like a 90% chance you're using one of these things. Okay, either the negative side or the positive side. All right, so it's something cubed plus or minus just a number. You're rocking one of those. You're going to have to use this formula in order to actually factor it down. There's an addition one. Do you want me to write it down real quick? Okay. So you need to know both of those formulas. I would suggest having them written down somewhere. All right. So everybody okay with the basics up here, though, with the canceling part? With the simplifying part? Okay. All right, dividing rational expressions. So how do you divide fractions? Who remembers? How do you divide fractions? Multiply by the of the right, top or bottom? Bottom. So we always multiply by the reciprocal of the denominator, which is the second fraction, right? We're saying this divided by this, so that means that the second fraction is the denominator. So we're going to take our numerator, and it always stays as is. It makes no changes. We convert to multiplication, and what do we do with the second fraction? Flip it. And then we just multiply like normal. So what's A times D? AD, and what's B times C? BC. So 2/5 divided by 7/3. Tell me what to write. 2/5 times 3/7, and then I multiply straight across, right? 2 times 3 is over 35. Is there anything I can do to make those smaller? Is there anything in common, any factors in common with 6 and 35? No. So I am done. Okay, so it's pretty much the same thing that we were doing. We're going to convert division to multiplication, and then we're looking for common factors from top to bottom. Okay? So again, I do not touch the first fraction. Multiply, flip the second one. All right, and then I'm going to put together. So is there anything I can do to make 7 smaller? No, that's just going to be a 7. Is there anything that I can factor out of 2x minus 3? Nope, so that's just 2x minus 3. Is there anything that I can factor out of x plus 1? Nope. So that's an x plus 1. Anything I can factor out of x plus 2? Nope. Okay, is there anything that I can do top to bottom to cancel to make things smaller? Is there anything that matches from top to bottom in parentheses? No. So all I can do to finish up is actually just multiply it out. So you can leave it like that, or I want to make sure that you understand that you can get to here. All right, x squared plus 3x plus 2. So this is what it would look like without parentheses. This is what it is with parentheses. Again, for me, this is an acceptable answer. Okay? Everybody okay with that? Yes? No? Maybe? So it's just like everything else we've been doing. It's just that we have to flip first and then multiply. Alright? After we multiply, we're going to simplify. So we're going to break things down into their pieces and then see what's the same on top that's also on bottom and remove them. Okay? You good? Yeah. So let's try one big one. Okay, so I'm dividing, right? Which means that I'm going to multiply by the reciprocal, so I'm going to actually just rewrite the entire problem here before we get too carried away. And I understand some of you are looking up here going, hey, I can skip this step and I can skip that step, but there is a lot of room for making changes up here. Some kids from last year would go from here to the line I'm about to write. They would go from step 1 to step 3. Okay, if you can see it, do it. If not, don't worry about it. Okay? So I'm done with this entirely. I don't care about that anymore. I've changed my division problem into a multiplication problem, right? So it's just like everything else we've been doing. I'm trying to factor down, right? So I've got 7x. Is there anything I can do to make 7x smaller? Huh. Yep, times the second fraction. So is there anything I can do to make 7x smaller? Can I factor anything out of 7x? Nope. So this is just a 7 times an x, but because I do like parentheses, right, I'm going to split that apart. Okay? So now factor x squared minus 11x plus 30. So I need two numbers that multiply together to get x squared, so what you got? Two numbers that multiply together to get 30, but when I add them, I get 11. Huh? 5 and 6, perfect. Now, are the signs going to match or be different? Same, and they're both negative. Everybody okay so far? Yes or no? Any questions on the top? All right, so now we're going to do the same thing on the bottom. Is there anything I can factor out of 2x minus 10? Okay, so I can pull out a 2. And what does that leave me with? X minus 5. What about x squared minus 6x? Is there anything I can pull out of that? Okay, just 1x. And what does that leave me with? X minus 6. So now everything's broken down into sets of parentheses, right? Everything's isolated, and everything's connected through multiplication. So what matches on top and on bottom? X minus 6, x minus 5, is that it? X. So what am I left with? So that's your reduced form. So what's crazy about this is regardless of what number you put in for x, you'll always get 7 over 2. It's actually a horizontal line. So this is your actual homework assignment. So the big thing for tonight is take a look at it.